You drop a file in blob storage and you want code to run. On Azure Functions, there are two ways to wire that up, and they look almost identical in your function attributes, but they behave completely differently in production. One is the classic polling blob trigger. The other is the event grid-based blob trigger. In the next few minutes, I'll show you how each one detects new blobs, the latency and cost you actually pay, where each quietly drops events, and a crisp rule for which to reach for. If you've ever shipped a file pipeline that worked in dev and went mysteriously slow at scale, this is why. The default blob trigger is the one almost everyone starts with. You decorate a function with a blob path, point it at a container, and new files invoke your code. Under the hood, it does not get a real notification. The function's runtime keeps a blob receipt store and periodically scans the storage logs and the container to find blobs it hasn't processed yet. For small workloads, this is fine and dead simple to set up. But that scan is polling, and polling has a tax. There is no service to configure beyond the storage connection, which is exactly why it's so tempting as the first thing you build. The polling trigger's weak spot is latency and scale. Because it scans, there can be a delay of up to 10 minutes between upload and execution on a busy container. And that delay grows as the container fills with blobs, because the scan has more to walk through. Microsoft's own guidance says if your container holds more than roughly 10,000 blobs, or you need consistent low latency, don't rely on the polling trigger. It can also miss events under heavy churn and depends on storage logging. It works, but it degrades exactly when your pipeline gets popular. Always check the current Azure docs, since these thresholds and behaviors get revised. The event grid-based blob trigger flips the model from pull to push. Instead of your runtime scanning, Azure Storage emits a blob created event to Azure EventGrid the moment a blob is written, and EventGrid pushes that event to your function. Latency drops to typically a few seconds and stays flat no matter how many blobs are in the container, because nothing is being scanned. EventGrid also gives you real delivery retries and dead lettering for events it can't deliver. The catch is setup cost. You now provision an EventGrid system topic and a subscription, and you depend on a second service in your architecture. Here's the honest comparison. The polling trigger wins on simplicity. One connection string, no extra resources, and it's perfect for low volume or batch jobs where a few minutes of delay doesn't matter. The event grid trigger wins on latency, scale, and reliability, with predictable seconds-level delivery and built-in retry and dead lettering, at the price of more moving parts and a small per million operations event grid charge. My rule of thumb: prototypes and low-traffic internal tools. Stay with polling. Anything customer-facing, high-volume, or latency-sensitive, go EventGrid from day one so you don't have to re-architect later. Architecturally, the EventGrid path looks like this. Your client uploads a blob to Azure Blob Storage. Storage publishes a blob created event to an EventGrid system topic. An event subscription filters on the event type and the container prefix, then pushes to your Azure function. From there, your function does the real work. Maybe it writes results to Cosmos DB or hands off heavy jobs to a queue. The key point is that the function is invoked by the event, not by scanning, and EventGrid handles the delivery guarantees between storage and your code. What surprises people is how small the code changes. In the .NET isolated model, you keep the same blob trigger attribute. You just set the source to EventGrid. The function signature, the path, the binding all stay the same. The behavioral switch from polling to push is one property. Everything else is configuration outside your code, creating the system topic and subscription, which you do in Bicep or the CLI. So migrating an existing polling function is genuinely cheap. The work is in the infrastructure, not the handler. So, to recap, The classic blob trigger polls by scanning your container, simple, no extra services. But latency climbs and reliability drops as you scale past roughly 10,000 blobs. The event grid-based trigger pushes events in seconds with retries and dead lettering, at the cost of an event grid system topic and a tiny per event charge. Here's your one actionable takeaway. If the pipeline is anything more than a low-volume internal job, start with the event grid source from day one. The code is nearly identical, and you avoid a painful re-architecture under load. And because thresholds and pricing shift, confirm the current numbers in the Azure docs before you commit. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.